All right. So the first thing we're going to do on our old notes is decide which of these things is a polynomial function. Now, guys, we haven't even talked about polynomial functions. So right now what you're doing is basically guessing, or maybe you have a sense for what a polynomial function is. So I am on my old notes, my old note packet, down at the bottom of the back side, not the practice test, the old notes. It would be page 14, the back of page 14 of the old notes. And I'm trying to decide which of those things are polynomials. So, those of you that can find the paper because you're organized, does anybody have a guess about any of them that you think are or aren't? I don't care which way we go, are or aren't polynomial functions. What did you say? A is one. Avery is exactly right. A is a yes. That's a yes. What about B? No, because why?
Is it because there's a negative on the exponent?
Negative exponent. You can't have a negative exponent. Those of you that can't find the sheet, you need to start writing. You need to write down these rules. You cannot have a negative exponent. Okay? What about number 3? Or C, I mean C. No, because why?
There's
No x in the denominator. So the rules so far, we have 2 rules so far. You cannot have a negative exponent, and you cannot have an x in the denominator. Okay. What about letter D? Do you think that's a yes or a no? That's a yes. Nothing wrong with that one. I mean, it is a very small little function. Very small. But it's okay. It doesn't break any of the rules. What about E? Yes. What about F? Actually, F is a yes. And I'll tell you why. H is a no. So those of you with papers, look at F and H and tell me what's different. Exactly. They both have radicals. But the rule is no x under a radical. That's the rule. What is under the radical in problem F? A 5. There's nothing wrong with that. The rule is no x under the radical. Okay? And finally, what about G? It's a no. The rule is no fractional exponents. So basically there are 4 no-nos. The 4 no-nos are no negative exponents, no fractional exponents, no x in the denominator, no x under a radical. So if you have an equation that doesn't have any of those things, then it's good. Then it's good. No negative exponents, no fractional exponents, no x in the denominator, no x under the radical. You have those 4 things written down? Okay. Because that will be a test question. It will say, is this a polynomial function? Why not? If not, why not? And if it has a negative exponent or a fractional exponent or an x in the denominator or an x under the radical, it's a no. Otherwise, it's a yes. Got it? Okay. Next one says, this is number 2, write the equation of the linear function where f of 2 is 3 and f of 1 is 5. That's the last problem in our old notes. It says write the equation of the linear function. Now wait a second. What do you think a linear function is? A linear function. What do you think it is?
A linear graph is something just straight.
The line,
Just a line.
right? Yeah, Sean's exactly right. It's a line. So this question is asking you to write the equation of the line. I know it says linear function and all that, but that's just a line. You're writing the equation of a line. Have you ever done that before in your life? Yeah, like
Yeah.
12,000 times. And what do you do when you write the equation of a line? Y equals mx plus b, which means you have to have what? What's m? The slope. Don't you have to find the slope? Okay, how do we find slope? Rise over run, y2 minus y1 over x2 minus x1, right? That's how we find slope. Now, in order to do that, we have to have points. We have to have x's and y's. Believe it or not, kids, these are points. This is just a fancy way of saying 2, 3. And this is just a fancy way of saying 1, 5. These are points. Function notation is f of x. This is the x value. 2, 3. 1, 5. So what's my slope? 5 minus 3 over 1 minus 2. I got -2. Did you get that? So the problem was written in a fancy new way, but it's really just points. So then I did slope, because I'm writing the equation of a line, so I did the slope, y minus y, x minus x, got -2. Now what do I do? Pick one of the points, I'll just pick this one because it's closest to me. And then what? It's called point slope.
Point slope, yeah.
So we're gonna do y minus 3 equals -2, x minus 2. Remember that? Y minus the y equals m times x minus the x. So y minus 3 equals -2x plus 4. So my function is y equals -2x plus 7. When I said, how do you write the equation of a line? A bunch of you said y equals mx plus b. Isn't that what I got there? Y equals mx plus b. Well, I think there's another one on your new notes at the top of page 15 of your new notes. There's another problem just like that. So, would you and your partner, while I put my attendance in, work on that problem? Yep, so it's at the top of page 15. At the top of page 15, turn around and work with that. Let's go. Come on, Sean, let's go. We're at the top of page 15, our new notes. We have our new notes now. And it's out there. So do you recognize that you've got ordered pairs, right?
Mm-hmm.
Once you find the slope, is y minus y1 equals parentheses x minus
What?
x minus x1. So like,
Yeah.
Oh, so this one we had two. Yeah, second. Which equation? So y minus y1 equals m, then you say parentheses x minus x.
so then you just do x, so you just pick one of the points and then put it in for y. And then it's like, so I just
What are the points in problem number B? What are your ordered
3,
pairs?
6, negative 4.
3, 6, and negative 4, negative 1. So take a moment, guys, and make sure that you got your points written correctly. The thing inside the parentheses is x, f of x. So if it's in the parentheses, it's an x. Okay, so what was your slope?
1.
I'm getting positive 1, negative 7 over negative 7, or 7 over 7, depending on which way you subtracted. So I'll just pick this point, y minus 6 equals 1 times x minus 3. I got x plus 3, y equals x plus 3 is my answer.
Yep.
Okay, the direction said, write the equation of a linear function. Sean said a linear function's a line. A bunch of you said lines are y equals an x plus b. There we go. That's it. Easy. Okay, now, the next section of the problem talks about things that aren't lines. What shape is problem A? Now look at that equation carefully. What shape is that? It's a parabola. How do we know it's a parabola? Because it's square, right? Now, the question wants to know 3 things. It wants to know the direction of opening of the parabola. So our parabola is either open up or down. So it's going to be up or down. They want to know the vertex, which is, like this point right here. And they want to know the axis of symmetry, which is the crease if you folded your parabola exactly in half. Okay? So somehow, from this equation, we are supposed to know all of those things. Well, what can you tell me about any of them? Does anybody have any thought on that equation, where its vertex is, which way it opens, anything like that?
Which way opens is
Up. Matthew says it opens up. Boys and girls, don't all of our parabolas open up unless you do what? Put a negative in front of it, because that's what turns it upside down. If we don't have a negative in front of it, it's going to open up, because that's what quadratics do, right? X squared, BFF, they're up, unless you put a negative number in front, which we didn't. Okay. On a test, you had to graph something that looked like this. Where did you put it? When you saw this right here, what did that say to you? 3 units to the right? And 4 units up. So if you were going to graph that, you're going to go over 3 and up 4. Where are you going to put that vertex? What point is that? Isn't that 3, 4? So that's your vertex. 3, 4. Ellie?
Could we just like plug this into our calculator to get the information like that?
Certainly your calculator will do it for you, but that's not the way we're doing it. We're gonna do it by hand. But certainly your calculator would.
So we won't have a calculator for this.
Huh?
So we won't have a calculator
No,
for this.
not for this. Okay? But you don't need one. Can't you tell that's over 3 up 4? Yeah, you know your rules. We spent a lot of time on those rules. That's all there is to it. Now, this axis of symmetry thing. For this problem, here's the parabola. Here would be the crease if I folded it in half. What is the equation of that line? X equals 3. Bingo. Your axis of symmetry is always going to be x equals whatever that number is. X equals 3. It's always x equals, and it's always whatever your vertex coordinate is. These two always match. Can you say easy? This is easy. All right, what about the next one? Let's look at B. Don't be confused, just think about this for a second. Think about what you already know. Where is this one sitting? Where is its vertex? Letter B.
1, 9, 15.
Where would you put it? Left one. Now, is it going up or down or anything? I mean, is it moving up or down? No, because there's no number on the end. That's a positive, so it opens up. So our vertex is -1, 0. Our direction of opening is up. What's our axis of symmetry? X equals -1. These always match. Always match. Oh my. This next one, oh my. How has that one been moved?
Oh, right.
Where is it sitting?
Up 4.
It only went up 4, didn't it? Is there anything in the parentheses with the X? No, so it didn't go sideways, it just went up.
Was that negative do anything?
So, well, does that here's my vertex, 0, 4, just straight up 4. This parabola went straight up 4. It did not go sideways because you don't have anything in the parentheses. Right? Now, somebody said, what does that negative do? Well, you tell me, what does that negative do out there in front? Flips it upside down. So instead of opening up, this one is going to open down. So your vertex is 0, 4. You're down, your direction of opening is down. What about our axis of symmetry?
0.
X equals 0. Remember, it's an equation. X equals this number right, I keep missing that number right there. All right, I don't want anybody confused by that problem. Remember when we had things like y equals f of x plus 4? What does that do? Doesn't that move you up 4? And when there was nothing inside with the x, all we did was go up 4. That's exactly what's happening here. There's nothing hooked to that x, like plus or minus, so you're not shifting it sideways, you're only going straight up. All right, would you try D on your own? Would you find your vertex axis of symmetry and direction of opening of letter D?
like when you like graph it, when it's in parentheses, you do the opposite.
All right, let's talk about it. What'd you come up with? What'd you come up with? What'd you say your vertex was? How has this thing moved? One right and down 2. So didn't that put you at the point 1, -2? Think about it. If you go right 1 and down 2, isn't that 1, -2? What does that make my axis of symmetry? Well, make sure you write x equals 1. You're only losing little fractional points because you don't write an equation. The axis is an equation. X equals. How about direction of opening? Which way is this guy open?
Down.
Down. Very easy. It's down because that negative right there. So you don't have to graph it, but if you did, it would look like this, right? How about E? Oh, this is the easiest one ever. Isn't that your BFF?
Yeah.
Where's the vertex of it? 0, 0. Which means your axis of symmetry is x equals 0. And which way does it open? Up. That's easy. That's your BFF. It hasn't moved at all. Last one, F. Where's my vertex? 2, 1, very good. Right 1, up, right 2, up 1, right 2, up 1. Making the axis of symmetry, x equals 2, beautiful. And because that number is positive, the thing is opening up. You got a handle on that? All right, this form of the equation is actually called the vertex form. And it's called the vertex form, just like this one. It's called the vertex form because you can give me the vertex just by looking at the equation, right? Just by looking at the equation, you can give me the vertex. That's why it's called the vertex form. Now, what I'd like you to do is I'd like you to turn not to the back side of that page and not to the front of the next page, but to the back of the second page, where it says find the vertex, direction of opening, and axis of symmetry. So I am on the back of the second page, which is a worksheet, but we're going to do it together. Go to the second page of the packet and go to the back. Go to page 2, the back of it, and you will be at the right spot. Now, take a look at the equation there in the first problem. Is it in vertex form? No. So if we want the vertex, we're either going to have to change the equation around and put it in vertex form, or we're going to use a little trick I'm going to show you. It's called the, it doesn't say it in there. Using the axis of symmetry formula. It's called the axis of symmetry formula. So here we go. We are going to find the vertex, the axis of symmetry, and the direction of opening for this equation. Now, there's a formula for the axis of symmetry. The formula is -b over 2a. So x equals -b over 2a. What do you think we mean by a and b? What do you think a and b are here? Sean?
It's like the quadrant point.
Exactly. So what's a? A would be 3, and b would be actually -6. So a is 3, and b is -6. So like Sean said, this is a quadratic equation, And if you were doing the quadratic formula, wouldn't this be A, this be B, and this be C? So for the axis of symmetry formula, you don't need C, you need negative B over 2A. So negative B would be positive 6, and 2A would also be 6. So your axis of symmetry is x equals 1. Everybody okay with that? So using our formula, negative b over 2a, we now know that x equals 1. How does that help me find the vertex, though? Olivia? Exactly. These two always match. So usually I know that first, but now I know this first, so I know this has to be a 1.
You can fill in one,
How do you find y? You go back and plug in x. So here we go. 3 times 1 squared, which is 1. PEMDAS, 1 squared is 1. Minus 6 times 1 plus 1. So what do you come up with there? I got negative 2. PEMDAS, when you plug in 1, it's not 3 times 1 squared. It's 1 squared times 3. Which way is it open? Up. Wow, that wasn't so bad. Let's try B. We need the vertex, the axis of symmetry, and the direction of opening. What's our direction of opening going to be this time? Down? Everybody okay with down? Now, where do we go from here? Who remembers what we did on the last one? Look at the last one. What do we have to do? We have to do our formula, which is negative b over 2a. All right, in this problem, what's a? What's my a? Negative 2. What's my b? 8. So negative b over 2a will be negative 8 over negative 4, which is 2. All right, so let's make sure everybody got 2. Everybody have 2? Okay, now where? That's my axis of symmetry. X equals 2. Now what? So 2 is the x-coordinate of my vertex. And now I'm going to go back to my equation, and I'm going to very carefully plug in 2 for all of the x's. Now when I say very carefully, I mean I get so frustrated with all the mistakes that happen right here. If I want to simplify this, I do 2 squared, which is 4, times negative 2, which is 8. Negative 8. So negative 8 plus 16 would be 8. And there it is, we're done. Now, some of you are probably freaking out because you're looking at the next one and, oh my gosh, it has a fraction in it. Do not fear that. Because remember, your formula is negative b over 2a. What what is the A and the B in this problem? A is 1/2, and B is -4. Now, the reason I'm not panicking is, when I do negative B over 2A, I'm gonna have +4 over 2 times 1/2. What's 2 times 1/2? 1. So that works out great. My axis of symmetry is x equals 4. Negative B, so 4, over 2 halves, which is 1. There it is. Your axis of symmetry is x equals 4. Now our vertex. We're going to have to plug in 4, but again, I'm not panicking. 1/2 times 4 squared minus 4 times 4 plus 1. I'm plugging 1/2 into my equation. I'm plugging 4 into my equation. What is 4 squared? 8. 8?
Wait, no.
4 squared is 16, but half of 16 is, half of 16 is 8. So it took us a minute, but we got that figured out. 4 squared is 16, and half of 16 is 8, minus 16 plus 1. What does that end up equaling? -7. Which way is it open? All right, there are 3 more problems, D, E, and F. Would you try those? Help each other. Find the vertex, axis of symmetry, and direction of opening of D, E, and F. Go. Now. Get alive. Perk up. It's Friday afternoon, last period of the day. I know you want to get out of here, but guess what? We're not. So let's learn some math. Practice some math. So we're doing D, E, and F. Finding vertex, axis of symmetry, direction of opening. You're doing them by yourself or with your partner?
It's the second number. Like you don't need to like YD. So it's
What?
Well, we're all supposed to be working on this, Madeline. Oh, where's your phone? All right, hurry up. Come on, you're supposed to be doing these problems. Let's go. No, we're doing D, E, and F. Let's go. You're done. When you're done, look up at mine. Mine could be wrong. I'm going to have you check it for me. If you have a question, ask it, because I could very well be wrong. I did them kind of fast. Don't want to have a mistake, so please, please, please let me know if you don't agree with me. So Avery, are you saying I have a mistake?
I am probably wrong.
No, you might be. Which one is it on?
On D,
D? What part is wrong?
I just had I had negative 12 over negative 6, which was a positive 2.
Okay, so A is negative 3 and B is negative 12. Is that right? Did I copy it right?
Yeah.
Okay. So remember your formula is negative B, so that'll be 12 over 2A, which is negative 6. So that's how I got negative 2. The formula is negative B, the opposite of B. Did anybody agree with me on question B? Okay, so we have some, okay. So does that make sense, Avery? And anybody else, that's the kind of feedback I need. You need to double check my answers.
I got a different Y on there.
On F, a different Y. So you got X equals negative 4?
Yeah.
All right, so 3 times negative 4 squared plus 24 times negative 4 plus 11. Make sure did I copy that right? Is that okay? All right, so what's negative 4 squared? 16. And 16 times 3 is 48?
Yeah.
Okay. What's 24 times negative 4? Negative 96. And then we have plus 11.
Yeah.
So what's 48 minus 96? I need to subtract those.
Oh, we just couldn't. I did
So
positive
that'll be
48.
negative 48
Yeah, I see what you're saying.
plus 11, negative 37. Yeah. So while you're finishing up and checking your answers, 2 things we've learned about parabolas here. One is, if the parabola is in vertex form, this is called vertex form, right? Because when the parabola is written like that, you can tell exactly where it's been moved. That's called vertex form. If the parabola is not in vertex form, then you're going to use our little formula, which is negative b, x equals negative b over 2a. Right?
Yeah.
All right. Oh, excuse me, I'm so tired today. Ellie, what was your question?
I was confused on E. I'm no longer confused.
Okay, super. Okay? All right, so now we are going to go back to page, in our notes, we're going back to page 15, and we're going to the back of page 15, where it says problem number 5. Okay, so find page 15 in your notes, that's the first page. Go to the back side of it, which says problem number 5. Okay, the back of page 15, it says problem number 5. All right, this is the last thing we're learning today. So let's hang in there and then we can maybe do some review. to get ready for next Tuesday's test. Alright, so this is what we're learning. We are going to do it backwards. Now I am telling you that the vertex of the parabola is -2, -3. Now, forget the rest of it. What can you tell me about my equation if the vertex is at -2, -3? What's that going to look like? What's going to be in the parentheses? Tatiana?
X plus 2.
X plus 2. Perfect. Because if you have x plus 2 in the parentheses, doesn't that mean you have moved 2 units to the left? Now, what's hanging on the end here that has moved me down 3? -3. Now, that is vertex form, except one thing is missing. What's missing? The number in front. I do not know what my A is. And that's an important thing to know because it tells me whether I open up or down, and it tells me how fat or skinny I am. All right? Now, luckily, they provided me with an extra piece of information. They said the parabola contains the point 1, 2. This is an X, and this is a Y.
Just fill
Fill it in. So if I put 2 in for Y, and 1 in for X, so look what I did. I put 1 in there for X, and I put 2 in there for Y. Now I'm going to be able to work that out and figure out what A is, aren't I? Now be careful when you do this. What's 1 plus 2 squared?
9.
So this is 9A. That's 9A. And then I still have the -3. So I'll add 3. And it's going to be 5 over 9. Now, I know that's a fraction. I know it's unpleasant. But remember, all you have to do is fill it in. So you're just going to write y equals 5 over 9 x plus 2 squared minus 3. You don't have to do anything with the 5 9s except put it back into the equation. Ellie?
How did you get the 9A?
1 plus 2 is 3. Squared is 9 times A. Okay, so let's look at the next one. Think about the steps we just went through, guys.
What?
Start with the vertex. Now, if you know the vertex, you should be able to fill in the parentheses and put the number on the end. What's going to go in the parentheses? X
X.
minus 0, or just plain X. So if you would rather do plain X, that's fine. I like X minus 0 because it shows me that's a 0, but it's the same thing right here. And then what's on the end? Plus 1. Guys, if the parabola has a vertex at 0, 1, hasn't it been moved up 1? And that means there's a plus 1 on the end of it. Now, the only thing missing, and you can write this either way, it doesn't matter. The only thing missing is that number. Luckily, they gave me the point 7, 3. That is not the vertex. The vertex I already plugged in. What do I do with 7, 3? So this is X, so it's going here. This is Y, so it's going here. So 3 equals A times 7 minus 0 squared plus 1. What is 7 minus 0? 7 squared is 49. So this is 49A. It's times A. It's 49A. Hey, Gabe, sweetheart, doodling and shading and coloring is not going to help us. We need to be focused and writing this down. Okay? I'm just like you. I'm so tired. They cannot put Math League, PSAT, and Open House in the same week for people who are 62 years old. It's just way too much. Well, we gotta stay awake. We got a job to do. All right, so 49A plus 1. So how do I solve that? Minus 1, that's gonna be 2. And then divide by 49. So again, I am getting a hideous fraction, but it doesn't matter because all you do with that fraction is write it down here. So y equals 2 49ths, x minus 0 squared plus 1. You don't have to do anything with that fraction except put it back into the equation.
If you get one where you can simplify the fraction, you can simplify it.
Always.
Always.
All right, we're gonna do one more problem, then we're gonna review, but I need everybody right now to try C on your own. Yep, try letter C on your own. Now, when kids make mistakes on these problems, it's because they're not careful about which point they're using. Remember, the one that you start with, the one that goes into the parentheses and at the end, that's got to be the vertex. That's the vertex. So Michael, tell me what you started with here. Okay, do you remember, Michael, when I interviewed you in Miss O'Brien's class? And you told me in that interview how studious you were, how serious you were about school, how goal-oriented you were, and it was all great, great stuff. All talk?
No.
Okay, then let's get focused. Let's get focused. No. Then you never get in for office hours, because I don't buy it. You're chit-chatting, you're screwing around, you're not paying attention, okay? And that's not gonna get us anywhere, except F-ville, okay, in summer school. So let's get focused. Somebody help him. If we know this is the vertex, how do we start building our equation, Ethan?
Y equals A, x plus 2 squared minus 1. Oh,
Minus 2.
Oh, I'm hearing some argument. Should this be a minus 2?
oh God, my bad.
Minus 2.
That needs to be a minus 2 because we have moved 2 units to the right.
Sorry, my bad.
That was right. Went 2 units to the right.
No.
Now, this is where we start. Now we need to figure figure out A. So we go back to the extra point. We start with our vertex. That's the most important point. Then we go back and pick up our extra. Again, kids make mistakes with this and you shouldn't. X is 4. So you're going to put 4 in for X. Y is negative 5. So you're going to put negative 5 in for Y. So X goes in for X. Y goes in for Y. Now, what's 4 minus 2 PEMDAS? 4 minus 2? 2 squared. So this is 4a. Negative 5 equals 4a minus 1. Add the 1, so negative 4 equals 4a. And a is negative 1. Then you go back to your equation, and where it said a, you are now going to put in negative 1. So your answer is y equals negative 1, x minus 2 squared minus 1. Okay? All right, let's set that, put that away, set that aside, put that in wherever you keep your things organized. We did just finish 2.1. So I don't want to make that homework due on test day because I want you preparing for your test. So that homework will be due on the Monday after fall break. All right? So 2.1 will be due in 9 days. You have 9 days to do 2.1. Okay? So get it done. 2.1. The date on that is the 25th. All right. Now, let's think about what we have been talking about. We have 9 minutes that we can do whatever you want to do to practice for your test on Tuesday. So think about those practice tests we did. What kind of problem do you feel like you need help with? Or you need another practice? Maybe look at the practice tests if you can't remember. If you can't remember even what's on the test guys, you probably haven't studied enough. You need to spend some time studying. Practice test, not notes, practice test. What do we need to do? Sean? All right, Sean wants to do a box problem, okay? So, for the box problem, you know your test is going to have a box problem on it. For the box problem, let's say we have a piece of paper. We need to know how big the paper is. So let's say the paper is, let's say 22 by 13. Okay, there's our paper. We're going to cut out the corners, fold up the flaps, make our box. So 4 questions associated with this. What is the equation for the volume? What is the domain? What is the maximum volume? And what is the size of the corners? All right? So we're going to need a calculator for this, but we don't need a calculator for this. What is our equation for the volume of a box if the paper is 22 by 13? 22 minus 2x. 13 minus 2x. X. There it is. Right? Now, domain. You're going to put in x, and you're going to put it between 2 numbers. 0 and half of 13. Does everybody buy into that? You're going to have a calculator. If you can't do half of 13, type it in. 13 divided by 2. Okay. Well, now we need to type in because that's how we find the maximum. So I'm gonna go to my window, and this is X min, this is X max, and Y min is always 0. So this is gonna be my setup. Not sure why there's talking. So 0 to 6.5, 0, and then I'm just gonna put in 300. I don't know what's gonna happen for Y max. Remember, this is the one where I gotta see the top of the hill? So I just put in 300 for Y max. Now I'll put in my equation. I'll clear out the old stuff and put in parentheses. And hit graph. Okay, this is what I see. What does that mean? That means I go back to my window, and when I put in 300, I might put in 400 now. Okay, that's better. Now I can see the top of the hill. I'm looking for that point right there, right? So second calc, maximum, looking for the maximum. Move my cursor over here, press enter, move it over here using my arrow button, press enter, and then put it in between those two boundaries I just set up, and it says that my maximum is 2.64 and 340.77. So this is X, this is Y. All right, did anybody else get that? So now I need to answer these two questions. What is the maximum volume of the box? 340.77 cubic inches. I'm assuming these were inches. What size corners would I cut out to give me that volume? 2.64 inches. Okay, Sean, there's the box problem. All right, we have time for another one. What else? Yep. So Josh wants to do a mixture problem. So I don't really have time to write out the whole problem, but it's something like how much 32% stuff should be mixed with 87% to get 12 gallons of 50%. Okay? So I've got two solutions. I've got some 32%, I got some 87%, and I want to get a 50% solution. So with this problem, it's amount times percent plus amount times percent equals amount times percent. 6 things, 3 amounts, 3 percents. Almost all of it's in the problem. How much, that's the amount, how much of 32% should be mixed with 87% to get 12 gallons of 50%. Right? When this is empty, it's the minus one. So it's going to be 12 minus X. When this one's empty, it's 12 plus X. And then